A particle is on a line starting at position 0, and it randomly moves forwards and backwards every second. And the probability that it moves forward is 50%, and the probability that it moves backwards is 50%. What's the expected position of this particle after n seconds? Okay, I know, that's too basic. Obviously the answer is 0, since it's like equal chance of moving forwards and backwards. Alright, so given that, what is the expected amount of time it would take for the particle to leave position 0 and come back to position 0? Now this problem is a lot more interesting and a lot trickier. I'm going to start off with defining two variables, e, which is the expected amount of time it takes to leave position 0 and come back to position 0, and en, which is the expected amount of time it takes to reach position 0 from position n. Notice that in the first second, the particle can move either to position -1 or 1, each with 50% chance. So therefore, E is equal to 0.5 times E -1 plus 0.5 times E1 plus 1 to represent the second that has elapsed. Also notice how E1 is equal to E -1 because of symmetry. It doesn't matter just how you look at it from the number line perspective. And then from that, we get that E equals to E1 plus 1. Next at position 1, there's an equal likelihood of going back to position 0 or moving on to position 2. Therefore, E1 is equal to 0.5 times 0, because it doesn't take any more steps once you're back at position 0, plus 0.5 times E2 plus 1 to represent that another second has elapsed. So what's E2? Do we do the same process for E1 but for E2, E3, E4 all the way onwards? No, because of this simple trick. Given that in this situation that each step is independent of one another, really the expected amount of time it takes to go from position 2 to position 0 is equal to the amount of time it takes from going from position 2 to position 1, then position 1 to position 0, and both of them are equivalent to one another. It's just both equally taking one step towards the left. Therefore, E2 is equal to 2 times E1. So let's plug in this insight into our formula for E1. We then get that E1 is just equal to E1 plus 1. And at first you might think that you got this wrong, but that's just what it is. So the only way that we can make that true is if E1 is infinity. So actually you would expect that it would take an infinite amount of time to go from position 1 to position 0. And therefore you would expect that it would take an infinite amount of time to leave position 0 and return back to it. I find this pretty unintuitive, but it is just true. It is expected to take an infinite amount of time to leave position 0 and come back to it.